Today I'll be giving you a rundown of the basics of trigonometry, which is a branch of maths which deals with the sides and angles of triangles and the relationships between them. We'll mainly be looking at right-angled triangles like the one on screen, and the relationships between the side lengths and internal angles, because that's what you need to gain a good foundation for your understanding of trigonometry. So let's say this triangle has side lengths 3, 4, and 5, and an angle over here. And the symbol I've drawn is the Greek symbol theta, which is the most common variable in trigonometry used to represent an angle. Now let's work on naming the sides of a right-angled triangle. The triangle is going to have a side called the opposite side, a side called the adjacent side, and a side called the hypotenuse. The side across from the right angle is always going to be the hypotenuse, and it's also always the longest side of a right angle triangle. The side opposite the angle is called the opposite side, so this depends on which angle we're looking at. And the remaining side, which joins with the hypotenuse to form the angle theta, is the adjacent side. And quickly before we move on, I just want to review the Pythagorean theorem, or Pythagoras' theorem. Even though it's not technically under trigonometry, it's still very important, so you can skip ahead if you're already comfortable with using it. But it's essentially just a squared plus b squared equals c squared, where c is the length of the hypotenuse, and a and b are the lengths of the other two sides. So in this case it would be 3 squared plus 4 squared equals 5 squared. So 9 plus 16 equals 25, and we can see that's true. And so Pythagoras' theorem works for all right-angled triangles, and by rearranging it you can basically work out a missing side length given two side lengths. Alright, now that we've established that, let's learn the three main trig ratios. These are sine, which is written as sin, cosine, which is written as cos, and tangent, which is written as tan. And this is the acronym that almost everyone uses to memorize these ratios. So, ka, toa. So, ka, toa. And this stands for sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse, and tan of theta equals opposite over adjacent. So that's just something you need to remember. So ka toa. So for this triangle, for example, sine of theta equals 3 over 5, because it's opposite over hypotenuse. Cosine of theta equals 4 over 5, because it's adjacent over hypotenuse. And tan theta equals opposite over adjacent, so it's 3 over 4. Alright, have a go at this example. This triangle has side lengths of 5, 12, and 13. So see if you can find sine, cosine, and tangent of theta. Alright, sine is opposite over hypotenuse, so it's 5 over 13. Cosine is adjacent over hypotenuse, so it's 12 over 13. And tangent is opposite over adjacent, so 5 over 12. Alright, now let's see how we can find an unknown side of a triangle using a known side and a known angle. Alright, so have a look at this triangle. We have an angle which is 27 degrees, a known side which is 6, and it's the hypotenuse, and we want to find the opposite side length, x. So to work this out, we're going to use a trig ratio. So we have theta, and we have the hypotenuse, but we want to find the opposite side. The trig ratio that uses the opposite side in the hypotenuse is sine, so that's the one we're going to use to find x. Okay, so sine of 27 degrees is x over 6, because it's opposite over hypotenuse. And we can very easily just rearrange this to find x. So 6 sine 27 equals x, which we just get from multiplying both sides by 6. And if you put that into your calculator, x is around about 2.72, approximately. Alright, here's a practice problem. Here's a triangle with angle 36 degrees, a side length of 4, and a missing side length of x. So see if you can find x. So we have the adjacent length, and we're looking for the hypotenuse. And the trig function which uses the adjacent and hypotenuse is cosine. So we're going to do cosine of 36 equals 4 over x, and then we're going to rearrange to find x. So next we can do x cosine 36 equals 4. And then x equals 4 over cosine 36. And if you put that into your calculator, it equals approximately 4.94. Alright, finally let's go over finding an unknown angle using known side lengths. So let's say we have an unknown angle theta, as well as an adjacent side with length 4, and a hypotenuse with length 7. So how do we find theta? Well, we have the adjacent and the hypotenuse, so we know we'll be using cosine, because that's just adjacent over hypotenuse. And to find an angle using the trig ratio, you actually need to use the inverse trig function. So theta equals inverse cosine, adjacent over hypotenuse. And that just equals the inverse cosine of 4 over 7. And if you put that into your calculator, you should get approximately 55.15 degrees. Alright, now let's try this example. Find the unknown angle theta in this triangle, which has a side length of 7 and a side length of 8. So we're going to use tangent, because we're given the opposite and the adjacent sides. So theta equals the inverse tan of opposite over adjacent, which is 7 over 8. And if you put that into your calculator, you get approximately 41.19 degrees. And that essentially covers the basics of trigonometry. So thanks for watching.